Glaciers in Western Canada by Keegan Hall. Climate change is becoming a major factor for mountain glaciers in Western Canada, such as the provinces of Alberta, British Columbia, and the Northern Territory of Yukon. Outside of the ice sheets of Antarctica and Greenland, Canada has more glacier cover than any other nation. Of the estimated 200,000 square kilometers of Canadian glaciers, 1/4 is found in the west of the country, and the remainder are in the Canadian Arctic archipelago. Many scientists are becoming more concerned what future effects the loss of these large freshwater sources will have on large areas that rely on them. This presentation will show some of the possible outcomes and what we can do to decrease some of these threats. Why are glaciers important? Glaciers are formed when snow accumulates in the winter but does not melt completely the following summer. As the Earth warms at a faster rate than it did, a combination of less snow and rapid melt is causing glaciers to recede in length and volume. A large portion of Western Canada's fresh water comes from glacier runoff, with many primary irrigation rivers on the prairies such as the North Saskatchewan River, the Red Deer River, Athabasca River, and the Bow River all being initially fed by glacier runoff. Water from these glaciers are crucial to many different ecosystems in the Rocky Mountains, foothills, and boreal forests, and Great Plains. Advantages glaciers provide. They provide fresh water source. When glacier ice melts, it provides many ecosystems with the necessary fresh water they need to survive. Hydroelectric power. Tarns and rivers fed by glaciers are often used for hydroelectricity. This is most prevalent in the southern interior Kootenays along the Nelson Valley in British Columbia. Tourist attractions. In many Canadian national parks, glaciers are used as a tourist destination. The revenue such as scenic Lake Louise, Columbia ice fields, the Jasper Walkway. They can also be used for skiing. Rich soil. Glaciers irrigate almost all of the Western Canada's farmland on the prairies. Without this freshwater, soil quality would decrease immensely. How climate change is affecting glaciers. As the Earth warms at a faster rate, the combination of less snow and rapid melt is causing glaciers to recede in length and volume. Mountain glaciers, given their sensitivity to warming, are showing the earliest and most dramatic signs of ice loss. As glaciers are lost, the streams and rivers they once fed begin to dry up. These dry stream beds become very dry and begin to stir up dust, which gets blown onto vegetation and snow, increasing the melting rate due to dark patches being formed and interfering with photosynthesis of plant life. In places like the Cline River in the Yukon, there's significantly more dust because the valley that the river flows through is essentially dried out. But the area still experiences katabatic winds coming from off the glacier, which are quite strong and blow the dust from the dried stream beds further out on the landscape, creating dust bowl scenarios. Methods being used to observe glacier loss. Scientists study the glaciers using a number of methods, including analyzing old photographs and remote sensing. Scientists also observe glacial stratations, or strati, which are scratches or gouges cut into bedrock by glacier abrasion. Old photographs are among some of the most useful because it gives scientists the accurate vision representation of what a glacier looked like exactly. The only downside is that it only gives a more recent history from the past 100 years. Glacial stratations determine more ancient history, and some strati can be dated back to the Ice Age. These are examples of glacial stratations. They are remnants of how far the glacier has moved over long periods of time. These examples are from the Pedersen Glacier in Alaska. These are perfect examples of how researchers use old photographs to measure glacial loss. Because these photos are dated and documented, we know that to the time that has passed. If you notice too, these photos are taken from the same spot. They can tell the same mountain from the formation in the background. Pedersen Glacier before summer 1917, Pedersen Glacier, Alaska after summer 2005. UNBC research locations in BC. The research team at UNBC is focusing their efforts on several glaciers and ice fields in BC. At each site, meteorological measurements such as air temperature, wind speed, precipitation, and humidity are being taken to better understand the controls of glacier nourishment and melt. The researchers are also measuring changes in thickness, extent, volume, and movement of hundreds of glaciers through the mountain ranges of Western Canada. This work requires the analysis of thousands of aerial photos, some of these which date back to 70 years ago. These are a lot of the areas. Northern Rockies, Central North Coast, Cariboo Mountains, Southern Rockies, Columbia Selkirks, Mount Waddington, and South Coast Mountains. Glacial timeline. First coal plant in Western Canada, 1874. The first coal-fired electric generator in Alberta began its operations outside of Lethbridge in 1874 to provide power to the coal mines. The first plant dedicated to providing power to the city of Lethbridge was built in 1893. This trend continued throughout Alberta and has had coal power plants in Western Canada for just over a century. 1885, creation of Banff National Park. Canada's oldest known national park was formed in order to preserve the area's natural beauty from westward expansion. This included hot springs, forests, and glaciers. Many more parks have been developed since then, such as the Kootenay, Yoho, and Jasper, all located in the Canadian Rockies. Montreal Protocol, the first international treaty designed to protect the ozone layer by phasing out the production of numerous substances that are responsible for ozone depletion. Glaciers have already slowly been on the retreat in many Canadian national parks. Much of Canada's tourism industry is starting to thrive on the glaciers, with many tours and ski resorts being key players in the market. 2020, present day. Glaciers are rapidly decreasing, with 70% of glacial mass that has been lost in the last 50 years. Although there is measures taking place like the elimination of coal power plants and glacial research being done, there are still many social and economic problems standing in the way. Future glacier loss, 2070. 80% of Canada's mountain glaciers will be gone if the major climate change solutions are not embraced. This will create major droughts and dust bowls throughout the Rocky Mountains and prairies. Forest fires will become more prevalent due to dry conditions as well. Many locations that once brought revenue through tourism will be completely gone, and Canadian farms that will continue to struggle due to the depletion of fresh water. Temperature increasing in British Columbia. British Columbia has warmed on an average of 1.4 Celsius per century from 1900 to 2013. This is higher than the global average rate of 0.85 Celsius per century. The northern regions of BC have warmed 1.6 to 2 Celsius per century, twice the global average. Southern coastal regions have warmed to 0.8 Celsius per century, roughly equivalent to the global average rate. Most of the annual warming trend has occurred in the winter. Most of BC glaciers are located in these northern and eastern regions, where temperatures have changed the most drastically. Fun facts about Canadian glaciers. BC has about 17,000 glaciers and Alberta has around 800. Glaciers cover 3% of BC's landmass. Between 1985 and 1999, the annual amount of water lost from melting glaciers in BC was 22 cubic kilometers. Close to 90% of BC's energy is hydroelectric, and melting snow and ice play a significant role. The largest glacier entirely in BC is the Klinkkalini Glacier, with an area of 470 square kilometers. What you can do to limit your impact. Developing of sustainable energy and elimination of fossil fuels / coal-fired power plants. Continue use of development of electric cars and public transportation. Controlled burns and prevention of uncontrollable forest fires. Limit skiing and snowmobiling on glaciers to limit dark spots and increase melting. Funding of glacial research. Voting for parties that promote strong policies on the forestry industry and oil and gas sectors. Moving forward, become net carbon zero. These are the resources I used for this presentation. Thank you for listening.